Hi, so today we'll be looking at this problem of present ionization. So it is found that a 0.01 molar of NH3 has undergone 4.2% ionization. The question is, find the pH value and the Kb value, and if the solution is acidic, basic, or neutral at the end. So first off, since we know the present ionization and we know the initial concentration of NH3, we can just find the concentration of OH minus at equilibrium. So basically, present ionization is the concentration of OH minus divided by the concentration of NH3 initially times 100%. So basically, we just isolate for OH minus and we get 4.2 times 10 to the minus 4 molar. This is also equal to the value of X in the IC table. So we have this reaction. This is the hydrolysis reaction. A hydrolysis reaction is when a substance is in the water and like this, but the water does not react with the substance. Since this is liquid, water is a pure liquid, so that is why we do not consider its concentration, and even in the expression of the Kb or Ka or any K value, we do not consider the liquid water. If it would be gaseous, then yes, but now because it's a pure liquid, we don't. So basically, this is our IC table. Initially, we have 0.010 molar of NH3, we have 0 molar of NH4 plus, and we have about 0 OH minus, because we know that at perfect water, when there's only water, pure water, the concentration of OH minus and H plus or H3O plus is 1.0 times 10 to the minus 7 molars. But this concentration is really negligible compared to this concentration, therefore we say it is about 0. But if here we had really small value, let's say we had 1.0 times 10 to the minus 9, then this would be significant compared to this. Then we would have to consider this value. But in this case, because this is really big, we do not have to consider it. So we can forget about this and forget about this. So basically this is minus X, since the reaction will shift on this side. We know this because initially we had 0 of these, so obviously the reaction will go over to this side. So we have plus X, and here minus X. And we know from here, the present ionization, that X is equal to this. So the concentration of these two is 4.2 times 10 to the minus 4 molars. The concentration of NH3 is 0.01 minus X, so we just do 0.01 minus this value. It gives us 9.6 times 10 to the minus 3. From these concentration at equilibrium, these three concentrations, we can find the Kb value for NH3. So we just write out the expression, the products over the reactants, and we substitute the values, and we get 1.8 times 10 to the minus 5. So this is the Kb value that they asked. Then we have to calculate the pH value. So pH value, first, what we can do, we can calculate the pOH value from the concentration of OH minus that we have calculated here. So then we can just substitute here, and then we get the value of 3.38. But this is the pOH. We are asked for the pH value. Hence, we have to do 14 minus 3.38 to get the value of 10.67. And then we have to evaluate if the solution is acidic, basic, or neutral. So we know this, we know that the pH is higher than 7, and whenever the pH is higher than 7, here, this is basic. And whenever it's below, it's acidic. Therefore, we can conclude that the solution is basic.